Today in a wave optics now to see one numerical. Numerical is based on the interference. The numerical is like this way, just you can see here. A beam of light is constituting a two wavelength 650 nanometer and 520 nanometer is used to obtain the interference fringes in Young's double slit experiment. Find the distance of third bright fringes on the screen from the central maximum for the wavelength of 650 nanometer. And second is here, what is the least distance from the central maximum where the bright fringes due to the both the wavelength coincide. Now we can get here in this numerical is given, that is the first lambda 1 is equal to 650 nanometer and lambda 2 is equal to 520 nanometer and n is equal to 3. Now we know that here for lambda 1 is equal to 650 nanometer, the third bright fringes therefore the distance from the central maximum, that is x is equal to n lambda, that is capital D upon small d. Now here given that is n lambda 1, that is we can write it n is 3, that is 650 nanometer into capital D upon small d. Solve this we will get here 1950 capital D upon small d nanometer, that is x. Now next is here let for lambda 2 nth bright fringes and lambda 1 is n minus 1 bright fringes. So you get here that is a n lambda 2 is equal to n minus 1 lambda 1. Keeping this value here, it is n lambda 2, that is a we know that here 520 is equal to n minus 1 650. Simplifying we will get here, so we can get here that is a n 520 is equal to 650 n minus 650. Therefore minus we will get here 130 n is equal to 650, therefore n is equal to 5. Therefore the distance from the central maximum for n is equal to 5 bright fringes. So you get your same formula here. Therefore that is a x is equal to nth lambda 2 capital D upon small d is equal to 5, that is a lambda 2. So you can get here 5 into 520 capital D upon small d, multiply here 5 to the 10, then that is a 26 capital D upon small d. So this is the distance from the central maximum for the wavelength of lambda 2 520 nanometer. So this will be distance in nanometer. So this way to understand this numerical. In this numerical we know that here the Young's double slit experiment n is equal to 3 and there are two wavelengths are given. Lambda 1 is equal to 650 nanometer and lambda 1 is equal to 520 nanometer. We to get here the distance from the central maxima for n is equal to 3 for the wavelength lambda 1 is equal to 650, and simplifying keeping the value and finally we know that x is equal to n lambda capital D upon small d, and here that is 3 lambda 1, that is we put here 650 capital D upon small d, that is not given here, so we'll get the answer in the form of capital D upon small d. Keeping this value, you can get here 1950 capital D upon small d nanometer. Now let lambda 2 wavelength lambda 2 the nth bright fringes from the central maxima, and for lambda 1 that is n minus 1 bright fringes. So we know that here n that is n lambda 2 is equal to n minus 1 bracket over lambda 1. Keeping a value of lambda 1 and lambda 2, and finally you can get n is equal to 5. Now for the nth bright fringes from the central maxima, the distance for the wavelength, that is lambda 2 is equal to 5 to 0 nanometer, that is x is equal to n lambda 2 capital D upon small d. Keeping this value, and finally you can get here that is 260, x is equal to 260 capital D upon small d nanometer. So this way to understand this numerical. Thank you very much.